In this video, we're going to classify quadrilaterals. So we're going to look and decide what type of quadrilateral it is and then prove that it's that type. There's a lot of ways to do this. What I think is the easiest is to find the slope of each side and also both diagonals. So I'll go through one of the slopes. If we're finding the slope of segment BC, and make sure you label it either M for slope or you actually write that you're finding the slope of segment BC, because remember, this is a proof, so we want to be really clear in our work. So you can either count when you're finding the slope up to rise over run, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you can do y2 minus y1 over x2 minus x1. So we could do 7 minus 5 over 10 minus 0, and we get 1/5. And then also remember to find the slopes of the diagonals. So this is all the math that we're going to have to do. Now we just have to go through and prove which type of quadrilateral it is. So first, is it a parallelogram? A quadrilateral is a parallelogram if both pairs of opposite sides are parallel. And we can tell that if the opposite sides have the same slope. So BC and AD, they both have 1/5. CD and AB, they both have 5/1, which means the opposite sides are parallel. So when we're proving that, we want to say, yes, it's a parallelogram, because we want to say what we know about parallelograms, which is that opposite sides are parallel, and then what math told us that opposite sides were parallel, which was that opposite sides had the same slopes. It might be something more specific than a parallelogram, so let's check and see if it's a rectangle. We can tell by the picture that it's not a rectangle, but we still need to prove that. In order for a parallelogram to be a rectangle, it has to have 4 right angles. And the way we can prove if they have right angles is if the sides next to each other are perpendicular, which means the slopes need to be opposite reciprocals. So if we look, for example, at BC and CD, BC is 1/5, CD is 5/1. They are reciprocals, but not opposite. They don't have opposite signs, so it's not a rectangle. And again, we have to explain the property that told us how we know it's not a rectangle, and then what math told us that it's not that property. So adjacent sides or sides next to each other aren't right angles. And we know that because their slopes were not opposite reciprocals. Let's check and see, maybe it's a rhombus. You can determine if it's a rhombus if it has 4 sides that are all equal lengths. That doesn't mean equal slopes, that means that their lengths are the same. So in order to prove the same length, you have to show distance. We don't have to go through and do the distance formula because we can show another property that we know is true about rhombuses. Their diagonals should be perpendicular. So that's where the slopes of the diagonals come in. -1/3 and 7/11 don't have opposite reciprocal slopes, so they're not perpendicular to each other. So again, we'll first explain the property and then how we knew that. And we know it's not a square because in order for a parallelogram to be a square, it has to be both a rectangle and a rhombus.